Welcome to session 2 of module 1, Principles of Combinational Logic. The contents of session 2 are, here we'll study some definitions and terms, literal, product term, sum term, SOP, POS, Minterm, Maxterm, Canonical SOP and POS form, and also for the given Boolean formats, given Boolean equation format, how to convert into Canonical SOP and POS form, and how to generate a switching equations from truth table. After completion this one, we'll look at multiple choice questions and assignments related to the session 2. Literal. What is a literal? A literal is a Boolean variable or its complement. Consider a Boolean variable x and its complement, which is represented as x bar. So that what is a literal here? X and x bar is a literal. Product term. A product term is a literal or the logical product and of multiple literals. Here when I say product, it is nothing but the and term. So that what is an example for this one? As it says, the product term is a literal. X is a literal or x bar is a literal. X, y, x ANDed with y, or x bar and y and z. It's a product term. Remember, product term is and term. Sum term is what? A sum term is a literal or the logical or of multiple literal. When I say sum, it is or term. So that what is an example for this one? X, x bar or y, x or y bar or z bar are examples for sum term. Sum of products. A sum of products is a logical or of multiple product terms. What to understand by this one now? It says logical or of multiple product terms. What to understand here? It is nothing but what? Or of and terms. It's called as sum of products. So that what we have the product terms here and we have a plus symbols between these terms. It is nothing but sum of product x y bar or x bar or yz or x y bar z bar is an example for sum of products. Next, what we have? Product of sum. As the name says, product of sum, what you understand by this one? It is a logical and of multiple or terms. So that how do you write it here? You can write it as and of or terms. Right? So the example what is shown here, x or y bar, x or y or z bar, y bar or z bar. This is an example for product of sum. Remember, product means and, sum means or. Next term to understand is mean term. A mean term is a product term that contains all of the input variables, each literal no more than once, that make up a Boolean expression. Here the mean term is nothing but a product term. But what kind of product term is this one? That contains all of the input variables, each literal no more than once. As you can see here, right? As you can see here, we have a product term, we have a product term and a product term, right? And here, as you can see from the example which is shown here, we have three variables, x, y, and z. But in this product term, one variable is missing. Which is the variable missing here? It is z, right? So that it's not a mean term. But here, if you see this x, y bar, z bar, right? All the three input variables are there as part of the product term, right? So that this one is an example for a mean term, right? When I say mean term, all the input variable should be there, each literal no more than once. We call that as a mean term. Mean term is nothing but a product term which contains all of the input variables. Next is max term. What is a max term? A max term is a sum term that contains all of the input variables, each literal no more than once, that make up a Boolean expression. It says Maxterm. Maxterm is a sum term that contains all of the input variables. Yeah, this is similar to the mean term. When I say mean term, it is a product term. When I say product term, it should contain all of the input variables. In similar lines, what is a max term? Max term is nothing but a sum term which contains all of the input variables. Consider example of three input variables A, B, and C. And how do you represent a max term? When A or B. Take an example, one sum term what you have is A or B. The other sum term what you have is A or B or C. Which is the max term out of these two sum terms here? It is the second one because it has all the three input variables A or B or C. It could be A bar or B or C bar, right? Each literal no more than once. We call that as a max term. Max term is nothing but a sum term which contains all of the input variables. Next is canonical sum of product. The sum of products, we call it as a SOP. Right? A canonical sum of products is a complete set of mean terms that defines when an output variable is a logical one. Here we list out all the mean terms are for all the input combinations for which the output variable is equal to logic 1. That we call it as a canonical sum of products here. Next, what we have is canonical product of sum. A canonical product of sum is a complete set of max terms that defines when an output is a logical 0. Here, we look for the input combinations which are max terms for which the output is logical 0. If you see, it says complete set of max terms. Max terms are nothing but sum terms which contains all of the input variables. Similarly, here canonical SOP, it says complete set of mean terms. When I say mean terms, it is a product terms which contains all of the input variables, each literal no more than once. Next, now we'll see how to convert the given expression or the formats into proper canonical form. And what are the two proper canonical form? Sum of mean terms and product of max terms. First, we'll see how to convert the sum of product equation into canonical forms using Boolean algebra. The first thing is you need to identify the missing variable in each AND term. In each AND term, when I say that, it is nothing but what? A mean term, and in the sense a product term here, right? What we have, right? And when AND the missing term and its complement with logical AND term. Now we consider a one product term, which is the product term we have it here. As you can see, I'll consider this is one, an AND term or a product term X, Y, right? Now to this one, first you need to identify which is the variable which is missing. Since there are three input variable X, Y, and Z, in this AND term, what is missing? It is Z which is missing. So that now what you do, you AND the missing term and its complement with the original AND term. So that what we have done it here, we have ANDed with Z or Z bar. We know that. What we know? A or A bar is equal to 1. So that if I add this equation also, there is no change to the equation here. Still remains X, Y because A or A bar is equal to 1. As we know the postulate, Boolean postulate here. And next what you do, now you expand this equation with the help of distribution property. So that how do you expand X, Y, Z or X, Y, Z bar? So that what we have, this is a product term, this is a product term which contains all the input variables. This is a product term which contains all of the input variables here. So that you convert it into what now? Canonical SOP form, right? Next, we'll see how to convert the product of sum equation into canonical forms using Boolean algebra. Here what we need to see is, identify the missing variable in each OR term. Here we'll consider one OR term. The OR term what we consider is this one, X or Y bar. This is one of the OR term. Now in this OR term, identify which is the variable which is missing now. Since there are three variables X, Y and Z, we know that Z is a variable which is missing. So that what you do now, OR the missing term and its complement with the original OR term. So that what I do here, OR Z bar. We know that. Now if I go to write the equation by Boolean algebra, we know that A bar is equal to what now? It is equal to 0. So that if I add this term also, there is no change to the original OR term, right? It still remains the same. Now with the help of distribution property, expand this one. How do you expand now? X or Y bar or Z, X or Y bar, Z bar. So that this is in sum term, this is a sum term, and this sum term is nothing but what? It contains all of the input variables with each literal no more than once. Similarly here also, we have all the three variables, right? So that what we have it now, for these are the max terms for which the output is equal to 0, right? So that we converted the sum terms, whatever the product of sum terms what we have, into proper canonical POS forms. Now we'll see a couple of examples so that you better understand how do you convert into the proper canonical SOP and POS form. See this example. Place the following equation into the proper canonical form. P is equal to function of A, B, C is equal to A B bar or A C bar or BC. Now just by looking at the equation, we know that it is a sum of product terms. This is a product term, A B bar is a product term, A C bar is a product term, and BC is a product term, and we have a plus symbol, right? So that it is a sum of product form, right? Now how do you convert into proper canonical? When it says proper canonical form, you need to convert into canonical SOP form. And what was the procedure I said? In the AND term, identify the variable which is missing. In A B bar, what is missing here? It is C. So that what you write now, A B bar, make this as a B bar, C or C bar. Now with the help of distribution property, write it as A B bar C or A B bar C bar. Similarly, the second AND term A C bar is A C bar here, B or B bar, A B C bar or A B bar C bar. BC is equal to BC, A or A bar is equal to A BC plus A bar BC. So that now what is the canonical SOP form here? Write all the product terms, what we have it, and see if there is any redundant term here. See if there is any redundant term here. See here, do we have it any? You can see from here, we have this term and this term. Both are same. We know one property, X or X. Right? This is equal to what? X. So that you write only one term here. Right? So that what is the final canonical SOP form here? P is equal to A B bar C or A B bar C bar or A B C bar or A B C or A bar BC. Next example, place the following equation into the proper canonical form. Now what is given here? F is a function of input, T is equal to F, which is a function of input variables A, B and C is equal to A or B bar or C. Just by looking at the equation, we know that it is a product of sum, right? Because this is a sum term, it's an OR term and you're ANDing that, right? It is a product of sum term. Now how do you convert into proper canonical? It is canonical POS form what you need to convert now. So that in the first OR term, see which variable is missing, A or B bar is is the odd term. To this, what we add now? C or C ANDed with C bar, as it is a POS form here. So that now with the help of distribution property, you can write this one as A or B bar or C, A or B bar or C bar. Similarly, for the second odd term, you can write it as B bar or C, or A bar is equal to A or B bar or C, A bar or B bar or C. So that what is a complete equation here, and remove the redundant terms. Now what we have it here, you can see that these two terms are same, so that you can write it only once. So that what is the final equation, the canonical POS equation, T is equal to A or B bar or C, A or B bar or C bar, A bar or B bar or C. Now we'll see how to generate the switching equations from to table. Now a table is shown here. Now if you see in the table, there are three input variables, A, B and C. Right? Now write the mean terms and max terms with designation. As you can see from here, there is small m and capital M. The small m stands for the mean terms and capital M is represented for the max term. And you can see the numbers 0, 1. These are the decimal notations for the mean terms. Small m 0. It's a mean term 0. Mean term 7. Similarly, what we have? Capital M 0 to capital M 7. So that these are the max terms 0 to 7. Right? Since there are three variables, 2 raised to 3 is equal to 8. So that we have 8 mean terms or 8 max terms here. So that how do you write it now? You can see from here A, B, C. Since 8 combinations, what we have 0, 0, 0. Mean term is a product term which contains all of the input variables, each literal no more than once. Right? So that how do you write it? Since it is 0, for the mean term, we write it as A bar, B bar, C bar. Similarly, what we have 0, 0, 1. We have 0, 0, 1. So that how do you write it? Since A is 0, B is 0, you write it as A bar, B bar, C is 1. So it is C here. But when it comes to writing the max term, it is nothing but what? How do you write it here? It is inversion of what we see the combination. It is 0, 0, 0. So that what you write here, since it is 0, for the max term, we consider that as A or B or C, because A, B and C are 0 while writing the max term here. Similarly, for 0, 0, 1, how do you write it? A or B. Since C is 1, you write it as C bar now. Everyone understood the difference between the mean term? How do you write the mean term and the max term? Mean term, how do you write it? As you see here, if it is 0, in positive logic, what we see, like if it is 0, we write it as A bar. If it is 1, we write it as A. We consider that while writing the mean term. But when writing the max term, it is the inversion of it. If it is 0, you write it as A. If it is 1, you write it as A bar there. Right? And that's how you write for all the 8 combinations here. Now we'll see how to convert the given mean term list into decimal equivalent notation form. Now a SOP equation is given to us, and convert this equation into, it says, shortened decimal notation form. Right? Now how do you convert? P is equal to A B bar C or A B bar C bar or A B C bar or A B C or A bar B C. So that how many product terms do we have it now? 1, 2, 3, 4 and 5. And all these product terms are mean terms. Mean term, there are 5 mean terms what we have it now. Now how do you decode this, the algebraic, the mean terms into decimal notation? How do you convert? Now here, as I said here, since it is A, B bar, C, since you're writing the mean terms, these are the mean terms, how do you write? If it is A, you write it as 1. If it is bar, you write it as 0, right? So similarly, what we have A, B bar, C. So that how do you write it? 1, 0, 1. For this one, A, B bar, C bar. Since it is A, you write it as 1. Since B bar and C bar is there, you write it as 0, 0. In decimal, it is 4. Similarly, for this one, A, B, C bar. How do you write it? 1, 1, 0. In decimal, it represents 6. A, B, C, right? There is no bar, so that you write it as 111. 111 in decimal is 7. Right? So that, now how do you write it in decimal equivalent notation form? You write it as P is equal to, and since it is a mean term, right, you put the summation symbol. This is the summation symbol, and you say that these are the mean terms for which the output, which is the P which is given here, it is equal to logic 1. So that what are the mean terms? 3, 4, 5, 6 and 7 as we got here. This is 3, 4, 5, 6 and 7. And some authors use this notation summation small m. Small m stands for the mean terms. Right? Everyone understood how to convert the algebraic equation, the SOP equation, into the decimal equivalent notation here. One more example we'll see. Express the POS equation in a Maxterm list in a shorthand decimal notation form. And what is the equation which is given here? A or B bar or C, A or B bar or C bar, A or B or C bar, A or B or C, A bar or B or C. Now, how do you do this one? How do you convert this into? Based on the binary weighing of each variable, right? Similar to what we have done there. But since it is a max term, see here it is a max term. Yeah, change it here. This is a max term. Now, how do you write it? I said that this is similar to the what we've done for the mean term. Make the correction, write this as a max terms. How do you write it? A or B bar or C. So that how do you write this one? Since it is a max term, here it is A. How do you write it? Do you write it as 0? Here it is B bar, you write it as 1. C is written, so it is 0. Everyone understand this one? Huh? If you see, I have written a line here. Max terms are the complement of the mean terms. Sense. If I have a mean term, if I want to get the max term equivalent of that mean term, which is equal to, take an example, it is written as maybe A, B, and C. So that what is the max term for this one? How do you get the max term? As I said here, max term is nothing but the complement of the mean term. A, B, C. Take the complement of that. Right? And apply the De Morgan's theorem. How do you write this equation then? By using the De Morgan's theorem, this could be written as what? A bar or B bar or C bar here. Right? If I know the mean term, take the complement to get the max term there. Right? So that what we have now, for second term, A or B bar or C bar. Now it is A, you write it as 0. Since we have B bar and C bar, you write it as 1, 1. In decimal, it is 3. You write it for all the 5 terms. So that what is the decimal equivalent notation for the given POS equation? You write it as P is equal to, and what symbol do you see here? It's a pi symbol, right? If you see a pi symbol, it means that it is a max term. It means that these are the max terms for which the output is equal to 0. That everyone remember the definition, the canonical SOP and the canonical POS definitions, what we studied. These are the max term for which the output is equal to 0. And some authors use the notation pi capital M. Capital M means it stands for max term. What are the max terms? 0, 1, 2, 3, 5. These are the max terms. We'll see one more example. Find the SOP and POS equation for output variables A and A bar in decimal notation form. Now for A and A bar, you need to write the SOP and POS equation in decimal notation form. Now how do you write it for A now? It says SOP sorry. For first we'll write it for A, the output variable A. Since it is a SOP form in decimal notation form, how do you write it? I'm sorry. Now how do you write for this one? Now you can just write like this. The decimals here 0, 1, 2, 3, 4, 5, 6, and 7. Now how do you, so that we know that it is mean term 2, 4, and 5. Since it is a SOP form, which is the notation which you use it here, it is summation symbol. So that what we have 2, 4, 5. Similarly, how do you write it for A bar here? A bar, the output is equal to 1, 1 here. There's 1 here. We have 1 here. So that it is 0 into this one, this one, this one, this one, and this one. So that what is the numbers here? 0, 1, 3, 6, and 7. That's what we have written for A bar. 0, 1, 3, 6, and 7. Now, how do you write the POS now? The POS is nothing but it is 0. Now look for zeros here. 0 here, 0 here, and 0 here. 0, 1, 2, 3, 4, 5, 6, and 7. Since you're writing the POS decimal notation for the POS, you put the pi symbol. Now, so that what we have now, 0, 1, 3, 6, and 7. That's what we have written here. A is equal to function of x, y, z is equal to pi. Since it is POS, you write it as pi. 0, 1, 3, 6, and 7. Now, how do you write it for A bar? Now, look for the zeros here. This is 0, 0 here, right? So, what are the terms we have? 2, 4, and 5, right? So, that what we have 2, 4, and 5 here. And also, you can easily write this equations. If you see this one, right? We have written the SOP equation here for A. It is 2, 4, and 5. Now, which are the terms which are missing here? The numbers which are missing here. Just by looking at that, 1 is missing, 2 is missing, 3 is missing, 4 is there, 5 is there, 6 is missing, and 7. So that what is the POS for A then? POS for A is nothing but the missing terms what you see it here. That's what we have now. We have 0, 1, 3, 6, and 7. If you know the SOP form, you can easily get the POS decimal equivalent notation there. Similarly, you can see here, we have 0, 1, 3, 6, and 7. What are the terms which are missing here? 2 is missing, 4 is missing, and 5 is missing. So that what is the POS for A bar here? It is nothing but 2, 4, and 5. Now we'll look at some of the multiple choice questions. The first one, for the given to table with 4 variables, write the canonical SOP form for output variable m. Now we have 4 variables. Out of these 4 variables, 3 are input variables, A, B, and small m, and the capital M, what you see is a output variable. Now write the canonical SOP form for output variable m. Now what do you mean by canonical SOP? Recollect the definition for canonical SOP. It is nothing but what? The sum of minterms for which the output variable is equal to logic 1. So that now you need to look for logic ones here and ones. And which are these terms now? Write this one: 1, 0, 1, 2, 3, 4, is 5, 6, and 7. So that what we have now? It is 3, 4, and 7. Right? Now 3 and 4 and 7. But what are the combinations? Since it is an algebraic form, 4 options what we're given in equation form. How do you write it? It is 0, 1, 1. 0, 1, 1 means how do you write it? It is A. A is 0. You write it as A bar Bm. Similarly, what we have here? 1, 0, 0. A, B bar, C bar. We have it here, right? We have that one. We have here, right? And next what we have? All ones. A, B, M. We have A, B, and M. So that which is the correct option here? It is A. We'll go to the second one. The 3 variable Boolean expression in decimal notation form is given below. What is the algebraic mean term form? What is the equation we have it? F is equal to XYZ is equal to summation M 0, 4, 7. The 3 variable Boolean expression decimal notation form is given. Now you need to write it in its algebraic form. How do you write now for this one? It is 0, 4, and 7. Zero. How do you write 0? Since there are 3 input variables, 0. How do you write down? This is X bar, Y bar, and Z bar. Similarly, 4. How do you write 4 now? It is 1, 0, 0. And we know that here it is X comma. X is a MSB bit, Z is a LSB bit. Now how do you write X, Y bar, and Z bar? Similarly for 7, how do you write it? 7 is nothing but all ones. So that this could be written as X, Y, Z. And see where you see these 3 terms now. Where you see these terms now? Anywhere you see the terms, you can have, you have it here. You have it here, right? And also you have it here, right? So that A is the right option. Third question, for the output variable A bar, what is the POS decimal equivalent notation for the given truth table? Now for A bar, what is the POS decimal? Since it is a POS decimal, right? So that you need to look for zeros now. Where are the zeros? We have it. You have it here. You have it here, right? Since it is POS, we know that this is 0, 1, this is 2, right? This is nothing but 2 now. 3 will be this will be 4, and this will be 5. So that since it is POS, you write it as a pi symbol, right? You know, all the 4 options, there is a pi. And now see the number where you have it, 2, 4, and 5. Where do you see that here? 2, 4, and 5. The option C is the correct answer. Next one, what is the decimal Maxterm notation for the given POS equation? The POS equation is given in algebraic form. Write it in decimal equivalent notation. What we have, A or B bar or C. Since it is a POS equation, A means what now? It is 0. B is 1. This is 0. This is 0. B bar and C bar. This is 1. This is 1, and this is 0. So that what is this stands for 0, 1, 0. It is nothing but 2. Similarly, what is this? 0, 1, 1 stands for 3. 1, 1, 0. It stands for 6. See where you see this one. It should be preceded with a pi symbol. And what are the terms we have? 2, 3, and 6. Where do we have it here? 2, 3, and 6. The option D is the correct answer. The fifth question, the sum of products is a Boolean expression containing, it says sum of products. Sum stands for what? Everyone remembers? Sum is nothing but what? Sum stands for or, product is an and term. So that what we have? Oring of and term. Anding of or terms. What is the correct option here? Oring of and terms. Sum of products. Or of and terms. Right? Option A is the correct answer. Sixth one, the canonical form for the given Boolean expression is. Now, what is the correct option for this one now? Canonical form for the given Boolean expression. It is given here. Now, how do you convert this one? You write it as what? P Q bar, or you write it as P. Yes. Now, which are the variables which are missing here in this one and this one? It is yes. How do you write it? Yes or yes bar. Right. Similarly, what you write it here? It is Q which is missing. Q or Q bar. Right. So that just by looking at this one, you can write this one as what? P Q bar yes, or P Q bar yes bar, or P Q yes, or P Q bar yes. We know that these two are redundant terms, and you need to write only once. Now see where you have it. You can see here we have P Q bar yes, we have P Q bar yes bar, but what we have it here again? PQ, yes, what we have it here, right? And also again, PQ bar, yes, is written here. It's a redundant terms. So that which is the correct option what we have? The final equation for this one, it is PQ bar, yes, or PQ bar, yes bar, or PQ, yes. So that what is the correct answer for this one? It is option B for question number 6. We'll go to the 7th one. When n is the number of binary variables in the function, the total number of mean terms or max terms is equal to, right? When n, 2 raised to n, if it is 2 raised to 2, you get it as 4 max terms or 4 mean terms. So that which is the right option for this one? The option number C. Question 8. A function is given in max term form as f is xyz is equal to pi 0, 2, 4, 5. Its mean term form, as I said here, I already explained in one of the examples. Now what are the numbers we have it here? 0, 2, 4, 5, right? It's a variable. Which are the numbers, decimal numbers which are missing? 1 is missing, 3 is missing, 4 is there, 5 is there, 6 is missing, and 7 is missing. And now it says mean term. Mean term means it should have summation symbol. Which are the two options then? We left out with only these two options, A and B. Out of A and B, which is the correct answer? Look for this number 1, 3, 6, and 7. You can see it here. Option B is the correct answer. Question number 9. A Boolean expression is given by f x y comma z is equal to x bar y bar z, or x bar y z, or x y bar z bar. The equivalent decimal notation is. Now, what is the equivalent decimal notation? It is 0, 0, and 1. 0, 1, 1, 1, 0, 0. It is nothing but what? This is 1, this is 3, and this is 4. you should see for the summation, right? One option is left out here. Out of this four, which is the correct one, where you can see these numbers 1, 3, and 4, it is option number 4. The last question. A 3-variable Boolean expression in decimal notation form is given by f xyz is equal to pi 0 to 3, 6. The corresponding algebraic form is. Now, how do you write this one now? Now we have 0. How do you write it 0 now? 0, 0, 0. We have 3 variables. Now, since it is a max term means what? 0, right? You write it as what now? Now, if you remember the mean term, first write the mean term. How do you write it? A bar, B bar, C bar. Now to take the complement of this one, take the complement of this one. Right? So that what you get now, A or B or C then. Right? Everyone got this one? So that next what we have? 2. How do you represent 2? 0, 1, 0. How do you write this one now? Right? It is 0. We write it as A or B bar or C. Similarly, 3. How do you write 3 now? 0, 1, 1. Since it is a max term, how do you write now here? 0 is A or B bar or C bar. And similarly for 6, how do you write it? 0, 1, 1. This is equal to what? A or, since it is 6 here, how do you write 6? 1, 1, 0. A or A bar or B bar or C. And see where you see these 4 terms now. Where you see these 4 terms, A or B, C. So yeah, sorry, just make the correction. The variables are X, Y, Z instead of A, B, C. So that what we have X, Y, Z here. This is what we have A, B bar, C. So that what we have X, Y bar, Z. Similarly, what we have A, B bar and C bar. Where do you see that here? We have it here, we have it here, and the third term is also here. Right? This next what we have 1, 1, 0. It is nothing but what? A bar, B bar, C. Since the variables are X, Y, Z, it is X bar or Y bar or Z here. Right? So all the 4 terms are here. So that which is the correct option? Option number B for the 10th question. Now we'll look at some of the assignment questions on session 2. Write the mean term and the max term Boolean output equations for the following 2 tables using variable names and in decimal notation form. You should write it in algebraic forms as well as in decimal equivalent notation forms for the output variables W and X both. Similarly for A, B, C and D also. Second question, convert the following equations into their requested canonical forms. Now the first one is given as SOP form. Now you need to convert into canonical SOP. Similarly, the second one is given as POS. You need to convert into canonical POS. The third one, what we have, it is again given it as SOP form. Convert into equivalent canonical POS form there. Third assignment question. Write each of the following Maxterm canonical formulas in algebraic form and construct their corresponding 2 tables. You need to come with an algebraic form. Once you have the algebraic form, construct the 2 tables. Normally what we have done from the 2 table, we wrote the switching equation. From the switching equations, we wrote the canonical SOP and the canonical POS in decimal equal notation form. Now what in? The canonical in decimal notation forms are given. Now you need to convert into algebraic form, and from the algebraic form, construct the 2 tables. These are nothing but what? These are the max terms for which the output is equal to 0, and for rest of the other combinations it is 1. Right? Everyone try this one. Write each of the following mean-term canonical formulas in algebraic form and construct their corresponding to tables. Right? In the problem 3rd, the max terms is given. In problem 4, the mean terms are given. You need to come with the algebraic form. From the algebraic form, construct the corresponding to table. Now here, these are the mean terms for which the output is equal to logic 1. For rest of the other combination, it is equal to 0. Thank you, everyone.